Download this code from codegive.com, link in the description below. OK, let's dive deep into the world of throttle position sensors, TPS, exploring their function, the signs of a failing one, diagnostic procedures, potential fixes, and even a bit of code related to TPS monitoring, for those with microcontroller/embedded systems knowledge. What is a throttle position sensor, TPS? The throttle position sensor is a crucial component in your car's engine management system. It's usually mounted on the throttle body, near the throttle plate, the valve that controls the amount of air entering the engine. Its primary job is to monitor the angle, or position, of the throttle plate and send this information as an electrical signal to the engine control unit, ECU, or powertrain control module, PCM. Here's why that's important. Fuel mixture control. The ECU uses the TPS signal to determine how much fuel to inject into the engine. A wider throttle opening, more air, requires more fuel to maintain the proper air-fuel ratio. Ignition timing. The TPS signal also influences ignition timing. More throttle opening generally means the ECU advances the ignition timing for better power. Transmission control. In automatic transmissions, the TPS signal is often used to determine shift points. Idle control. The TPS provides feedback to the ECU to maintain a smooth idle. Engine load. The TPS signal provides information about the engine load. This informs various engine operations such as EGR valve control, and boost control, in turbocharged engines. In essence, the TPS is a key sensor that helps the ECU make decisions about how to optimize engine performance, fuel efficiency, and emissions. How does a TPS work? Most TPS sensors are basically potentiometers, variable resistors. They consist of a voltage source. The ECU provides a reference voltage, typically 5 volts, to the TPS. A resistive track. A track of resistive material. A wiper, or arm. This wiper is mechanically linked to the throttle plate. As the throttle plate rotates, the wiper moves along the resistive track. An output signal. The output signal is the voltage at the wiper. This voltage varies proportionally with the throttle plate position. When the throttle is closed, idle position, the wiper is at one end of the resistive track, and the output voltage is usually low, close to 0 V. As the throttle opens, the wiper moves along the track, and the output voltage increases towards the reference voltage, 5 V. 9 symptoms of a bad throttle position sensor. A failing TPS can cause a variety of drivability problems. Here are some of the most common symptoms. 1. Check engine light. This is often the first sign that something is wrong. The ECU detects an abnormal TPS signal, out of range, erratic, or no signal, and sets a diagnostic trouble code, DDC. Common codes related to the TPS include P0120, throttle/pedal position sensor/switch circuit malfunction. P0121, throttle/pedal position sensor/switch circuit range/performance problem. P0122, throttle/pedal position sensor/switch circuit low input. P0123, throttle/pedal position sensor/switch circuit high input. P0125, insufficient coolant temperature for closed loop fuel control. P012F, throttle/pedal position sensor/switches/B voltage correlation. P0220, throttle/pedal position sensor/switch B circuit malfunction. P0221, throttle/pedal position sensor/switch B circuit range/performance problem. *P0222, throttle/pedal position sensor/switch B circuit low input. *P0223, throttle/pedal position sensor/switch B circuit high input. Too rough or erratic idle. *A faulty TPS can send incorrect signals to the ECU, causing it to miscalculate the air-fuel mixture at idle. This can lead to the engine idling too high, too low, or fluctuating up and down. 3. Stalling. Similar to a rough idle, an inaccurate TPS signal can cause the engine to stall, especially when coming to a stop or when decelerating. 4. Hesitation or stumbling during acceleration. When you press the accelerator, the TPS signal is supposed to smoothly increase, prompting the ECU to provide more fuel. If the TPS signal is erratic or has dead spots, the engine might hesitate or stumble as you accelerate. This can feel like a lag or a momentary loss of power. 5. Surging. Surging is when the engine RPMs suddenly increase and decrease on their own, without you changing the accelerator pedal position. A faulty TPS can cause this by sending fluctuating signals to the ECU. 6. Poor fuel economy. If the ECU is receiving inaccurate information from the TPS, it might inject too much or too little fuel, leading to reduced fuel economy. 7. Difficulty shifting. Automatic transmissions. As mentioned earlier, the TPS signal is often used in automatic transmission control. A faulty TPS can cause erratic or harsh shifting, delayed shifts, or failure to shift properly. 8. Lack of power. An inaccurate TPS signal can prevent the ECU from delivering the correct amount of fuel and spark timing, resulting in a noticeable decrease in engine power. 9. Jerky throttle response. The throttle response may feel uneven or jerky. Instead of a smooth, linear increase in power, you might experience sudden bursts or dips in power as you press the accelerator. Diagnosing a bad TPS. 1. Read the diagnostic trouble codes. DTCs. Use an OBD2 scanner to retrieve any stored DTCs from the ECU. This will give you a starting point for your diagnosis. 2. Visual inspection. Check the TPS connector for corrosion, loose wires, or damage. Inspect the wiring harness leading to the TPS for any signs of wear, fraying, or damage. Look for any physical damage to the TPS sensor itself. 3. Voltage testing, with a multimeter. Reference voltage. With the ignition key in the on position, engine off, use a multimeter to check the reference voltage at the TPS connector. You should typically see around 5 volts. If not, there may be a problem with the ECU or the wiring. Ground. Check the ground connection at the TPS connector. You should have good continuity to ground, close to 0 ohms resistance. Signal voltage. Connect the multimeter to the TPS signal wire. With the throttle closed, idle position, the signal voltage should typically be around 0.5 to 1.0 volts. Slowly open the throttle, and observe the signal voltage. It should increase smoothly and linearly to approximately 4.5 to 5.0 volts at wide open throttle. What? Look for any sudden drops, spikes, or flat spots in the voltage reading as you move the throttle. These indicate a problem with the TPS. 4. Live data monitoring. With a scanner, many advanced OBD2 scanners can display live data from the TPS. This allows you to monitor the throttle position percentage or voltage in real time as you open and close the throttle. This is useful for detecting intermittent problems or subtle variations in the signal. 5. Resistance testing. If possible, some TPS sensors allow you to measure the resistance between the terminals. Consult your vehicle's service manual for the correct resistance values for your specific TPS. Then, measure the resistance as you move the throttle. The resistance should change smoothly and linearly. TPS fixes. 1. Cleaning the connector *. If you find corrosion or dirt on the TPS connector, clean it with electrical contact cleaner. 2. Repairing wiring *. Repair any damaged wires in the TPS harness. This might involve splicing in new wire sections or replacing the connector. 3. Adjusting the TPS. If adjustable, some older TPS sensors are adjustable. Consult your vehicle's service manual for the proper procedure. You may need to adjust the TPS to achieve the correct idle voltage. 4. Replacing the TPS *. If the TPS is faulty and cannot be repaired, you will need to replace it. Disconnect the negative battery cable. Disconnect the TPS connector. Remove the screws or bolts that secure the TPS to the throttle body. Install the new TPS in the reverse order. Reconnect the negative battery cable. You may need to perform a throttle position sensor relearn procedure using an OBD2 scanner. This is especially important for newer vehicles. The relearn procedure helps the ECU learn the new TPS's voltage range and ensures proper operation. 5. Throttle body cleaning *. Sometimes, a dirty throttle body can mimic the symptoms of a bad TPS. Carbon buildup around the throttle plate can interfere with its movement and affect the TPS signal. Clean the throttle body with throttle body cleaner, following the instructions on the can. Important notes *. Consult your vehicle's service manual *. Always refer to your vehicle's service manual for specific diagnostic procedures, voltage values, and adjustment instructions for your particular make and model. Use quality replacement parts *. When replacing the TPS, use a high-quality part from a reputable manufacturer. Cheap aftermarket parts can sometimes cause problems. Throttle relearn *. After replacing or adjusting the TPS, perform a throttle relearn procedure if required by your vehicle. This helps the ECU learn the new TPS signal range. Code example, microcontroller/embedded systems. This example shows how you might read the TPS signal using a microcontroller, like an Arduino, and translate it into a throttle position percentage. This is a simplified illustration and would need to be adapted for your specific hardware and application. Explanation of the code *. 1. Constant TPS pin equals A0, defines the analog pin on the Arduino that's connected to the TPS signal wire. 2. Const float reference voltage equals 5.0, sets the reference voltage of the ADC, analog to digital converter, used by the Arduino. This should match the voltage supplied to the TPS. 3. Analog read, TPS pin, reads the analog voltage from the TPS pin and returns a value between 0 and 1023, for a 10-bit ADC. 4. Float voltage equals sensor value *, reference voltage /1023.0, converts the analog reading, 0 to 1023, into a voltage value. 5. Float throttle position equals, voltage/reference voltage, *100.0, calculates the throttle position as a percentage based on the voltage relative to the reference voltage. 6. Throttle position equals constrain, throttle position, 0.0, 100.0, ensures that the throttle position percentage is always within the valid range of 0 to 100%. 7. Serial.print, prints the sensor value, voltage, and calculated throttle position to the serial monitor for debugging and monitoring. Important considerations for code *. Calibration *. This code assumes a linear relationship between the TPS voltage and throttle position. In reality, the relationship might be slightly nonlinear. You might need to calibrate the code to compensate for this. You could do this by mapping specific voltage values to known throttle positions, example 0% throttle, 50% throttle, 100% throttle. Filtering. The TPS signal can be noisy. You might want to implement a filtering algorithm, example a moving average filter, to smooth out the signal. Error handling. Add error handling to detect out of range TPS values or sudden signal changes that could indicate a fault. Application specific logic. You'll need to adapt this code to your specific application. For example, you might use the throttle position information to control a servo motor, display the throttle position on an LCD screen, or send the data over a communication bus. Safety critical systems. If you're using the TPS signal in a safety critical system, example controlling engine speed, you'll need to implement robust error detection and fail-safe mechanisms. In summary, the TPS is a critical sensor for proper engine operation. By understanding the symptoms of a failing TPS, following diagnostic procedures, and performing appropriate repairs or replacements, you can restore your vehicle's performance and fuel efficiency. Remember to consult your vehicle's service manual for specific instructions and always prioritize safety when working on your vehicle. And for those with embedded systems expertise, a bit of code can help you monitor and interpret the TPS signal in your custom projects.